Hello. Um, I want to give a short discussion now in regards to the ice ages. That is a question that has fascinated me all my life. I mean, ice ages reoccur on a regular basis. We've had approximately 20 or so in the last 2.25 million years. They've reoccurred regularly, and I see no reason why they won't reoccur in the future, possibly in the near future. And I have been thinking about this quite a lot during my life, and I've actually put together my own theory as to why ice ages occur. The reason I came up with my own theory is because, as far as I can tell, uh, in the research that I have done, is the scientific community doesn't seem to have what I consider a viable answer to this question. The accepted theories of the scientific community as regards the reoccurrence of the ice ages is that they reoccur because of a cooling period that's caused by something called the Milankovitch cycle, which has three factors, which include the angle of the Earth's axis in relation to its orbit. Depending on the angle, the variation in the angle, it can have either a cooling or a warming trend in the high latitudes. The actual shape of the orbit of the Earth around the Sun, when it's more elliptical rather than circular. The Earth spends more time further away from the Sun, and that obviously has a cooling influence. And of course there's the cyclic variation in energy output of the Sun, which also, can give Earth a cooling trend. And when all these three features are in a cooling mode, then the scientific community, the accepted wisdom is that that's what causes the ice sheets to advance. Now, I personally am not completely happy with this theory, and this is partly because snowfall is the only thing that can feed ice sheets. Ice sheets don't just form because it gets cold. If it's dry and cold, no ice sheets form. It has to be a high precipitation, which of course, if the temperature is cold, it falls as snow. And at the moment, the Arctic lands above the Arctic Circle, that huge landmass that surrounds the Arctic Ocean, has a very low precipitation rate. Much of it is technically a desert, and a desert technically is a place that has less than 10 inches of liquid precipitation a year, which translates into approximately between 30 inches and 36 inches of snow a year, and most of the land above the Arctic Circle does fall into that category. And because the snowfall in that huge area, that landmass, is relatively light, it all melts during the summer. The Arctic summer is relatively short, depending on where you are. It's anything from 8 to 10 to 12 weeks, and that's about it. But although it's a short summer, it's quite intense. It has 24-hour sunlight, and so actually that huge landmass during that short summer absorbs a great deal it has a high albedo. It absorbs a lot of solar energy. This is also enhanced by the fact that this huge landmass, the tundra, most of it is covered with plants that have evolved to absorb a lot of sunlight because they have to do their whole reproductive cycle in the short summer. So basically, because this huge landmass is devoid of snow for the summer and is absorbing a lot of the sun's energy, the overall trend of the climate in the northern hemisphere in the high latitudes is a warming trend, because of course year in, year out, by this absorption of large amount of solar energy. There are variations. There are periods where it appears to be cooling, and then there are periods when it's warmer than usual. I think the warm period I'm thinking of is prior to about 1400, when the Vikings actually managed to raise cattle and grow potatoes in southern Greenland. That was a warming period. And then after that we came into a cold period. Now these periods, variations in the upward trend of the temperatures in the northern hemisphere are quite possibly caused by the Milankovitch cycle and other factors such as the variation in ocean currents and that kind of thing. But the overall trend of the climate is towards warming in the northern hemisphere between the ice ages. And it gets to the point where we're at now, where the climate is warm enough that the Arctic Ocean is actually becoming free of ice for much of the year. The ice is much thinner than it was 30 or 40 years ago, and the area that is covered with ice every winter, the area of the Arctic Ocean that is covered with sea ice, is much less than it was, and it seems to be getting less every year. And a few years ago, I think it was 2005, there was actually open water at the pole for a period. And so we get to the stage we're at now, where the Arctic ice is thinning and melting, and I believe in this century, and possibly in the next couple of decades, the Arctic Ocean will be free of ice. If not all year, at least for most of the year. And when that happens, when the Arctic Ocean is free of ice, then the winds blowing off the Arctic Ocean, the maritime air, will be able to pick up a lot more moisture from the ocean. The reason the snowfall, the precipitation, is at the moment pretty low in those northern lands is because the winds blowing off the Arctic Ocean are actually relatively dry. And they're relatively dry because the surface of the ocean is under a layer of ice, and the winds blowing over the ocean cannot pick up much moisture, if any, from the ice. But when that ice is gone, then those winds blowing off the Arctic Ocean onto the land will have a great deal more moisture in them. And this will manifest itself as an increase in precipitation. And this increased precipitation will lead to the formation of permanent ice fields in the high latitudes. In other words, if the snow is 5 times greater than it is at present, or maybe even more than that, then it may be thick enough in one given summer, the snow might be thick enough that it doesn't melt during the summer. And you only have to have one summer when the snow doesn't melt, and then you have another high snowfall, and it won't melt the following summer. And so you've got the beginning of a permanent snowfield. And this will happen in various places because there are microclimate variations in the Arctic lands. And so you'll get the formation of permanent snowfields, and every year these will get bigger and bigger, and eventually they'll join up, coalesce, and you'll get large areas of permanent snowfield, and that is the beginning of the glacial advance. And as these permanent snowfields get deeper and thicker and heavier, and will compress into ice and form the ice sheets that we all imagine covered the northern hemisphere, that did cover the northern hemisphere during the ice ages. And interestingly enough, people think that during the ice ages it must have been, oh God, it's pretty cold up there now, it must have been a damn sight colder during the ice ages. And I say no, I don't think that was the case. I think the Arctic Ocean during the ice ages, during the glacial advances, I think the Arctic Ocean was free of ice most of the time, most of the year, and it was probably warmer than it is now, or maybe about the same temperature it is now because the ice is actually melting. And that Arctic Ocean that was free of ice absorbed a lot more sunlight itself, because dark water absorbs a lot more sunlight, a lot more solar energy than does the ice that covers the Arctic Ocean. And so once you have an Arctic Ocean that's free of ice, it sort of comes up a positive feedback, and it tends to stay free of ice because the Arctic Ocean itself is being warmed by the sunlight. And so with this high precipitation, you get the permanent ice fields extending further and further south from the high latitudes, and they actually promote cooling because the permanent ice reflects a lot of the solar energy back. The short, intense summer sunlight, most of that will be reflected back into space from the ice sheets, and so the extending ice sheets will be a cooling influence, but the ice-free Arctic Ocean will be a warming influence. And so it will take several thousand years, maybe several tens of thousands of years, for the warming trend of the high Arctic climate that caused the melting of the polar ice cap, before it'll be several thousand years, maybe several tens of thousand years, before the warming trend tips over slowly and becomes a cooling trend. And then as the ice sheets extend further and further south and cover a greater extent of the land, then more and more of the solar energy will be reflected back into space, and this cooling trend will continue until it will reach a point where the cooling trend will overcome the warming factors affecting the Arctic Ocean, and the Arctic Ocean will in fact permanently freeze over again, which is a situation that we have known in recent history. In fact, we're just about on the edge of that time now. And so once the Arctic Ocean freezes over again permanently, then the moisture is and the air blowing off the Arctic Ocean is unable to absorb the moisture. The precipitation that is feeding the ice sheets will suddenly be shut off and become very minimal, and the ice sheets will then retreat again. And the ice sheets will retreat pretty quickly because their feed source, the high precipitation, will have stopped, and they will actually retreat pretty quickly. In the last ice age, we know, was at its zenith, was at its apogee with the thickest ice, the greatest extent, about 17,800 years ago. And it pretty well had gone in 5,000 years, which might sound like a long time to an individual human, but actually it's a very, very quick retreat of that massive ice sheet that was 3 or 4 kilometers thick and covered millions of square kilometers. And once the ice sheets have gone and the Arctic Ocean is frozen over and the precipitation is low, you enter the cycle that we've been in for the last 10,000 years ago, or at least since the last ice age melted. The ice sheets of the last ice age is melted, and then the land is free of snow during the summer, and the temperature and the northern climate starts to warm again, and it continues to warm for, as I say, 10,000 years or so, until we get to the point we're at now, when the Arctic Ocean will no longer be under permanent ice cover, and the precipitation will increase, and the cycle will repeat. And that's what I think happens. I think the trigger for the advance of the glacial ice sheets is actually the melting of the Arctic ice. And that's what I think is the point we've reached now, and I think the human activity that is undoubtedly warming the climate, especially in the far north, is actually hastening the onset of what we call the next ice age. And I think this is very interesting, and I'd like to hear input from other people, preferably climatologists, paleoclimatologists and scientists, and see what they think of the Peter Johnston theory of the cause of the ice ages. And with that, I'll bid you adieu, and thank you very much.